So we will take this propositions and the compound propositions and see how they are equivalent. There are many ways to do this. One using the laws that we learned, and that's still doable. And let's say for here, in this case, P implies Q, we use uh, the conditional disjunction law, right? So here P implies Q, P implies Q uh, can be written as not P or Q. That is the law, right? So we are going to just expand that. So not P or Q, all right? And here we can also rewrite the left hand side if you want to just take that. So this one, if you not P implies not Q, if you use the same formula here, so this basically Q or not P, right? Yeah. So now I can rewrite this left hand side as not P or Q, and which is same as what we have on the left hand side, right? This is one example, simple example, but this is very simple, right? I mean, not everything will not be that easy. So let's take another example here, all right? Now we will look at another one. P implies Q and P implies R. It implies P implies Q and R. We'll see how that is, right? So we have hand sign. It says P implies Q and P also implies R. That's what it means. So P implies it's AND here, right? So we should have AND. So let's proceed from the left hand side. Let's use this conditional disjunction substitution like we did above. Right? So we have used the conditional disjunction for. And what we will do now is here we'll use the distributive law. If you see the distributive law here, there is a common proposition here, and we have the or here on the either side and operator. So this one is the distributive law. It's simple, right? So you have to know what the distributive law is, right? If I write down here A or B intersection C, according to the distributive law, A or B intersection A or C, right? So this is what the distributive law says. So here I am going to do the same thing. Look at here, A is common on both sides. We are now going from the right hand side to the left hand side here. We are going to use this particular stuff on the right hand side and substitute with the left hand side. So here I am common again P or Q and R, right? So I used the left hand side, and now if you look at this guy, this one again I can use the conditional disjunction formula to replace P implies Q and R. Simple. Not rocket science. We just used in 3 steps, we're able to arrive at the right hand side. It's very easy, right? So let's look at some more examples. So here we have another example. P implies R, Q implies R. It's and here, remember that, and implies R. It means P or Q implies R. Let's see how that is, right? Sometimes it's hard to imagine, but let's try to prove it. Like I said, this is not a rocket science. We will use the conditional disjunction formula here. So not P or Q, or, and not Q or R, right? Now let's rearrange all these things to and see again. If you look at the give me a second. If you look at here, R is common. Okay, let me say R is common, and here or on both sides. So what kind of law we have to use? Distributive law, right? Apply distributive law. So how does it work? Distributive law says A and B or C is equivalent to A or C and B or C, right? Same thing, very identical. Now apply the right hand side and use the substitute with the left hand side here, right? So this one transforms into not P and not Q, right? Sorry. And not Q or, all right? And so we have used the distributive law to come here, right? And now if you see the De Morgan's law here, De Morgan's law states what? A union B complement is equivalent to A complement intersection B complement. That's what we have here, right? Now we are going to use the same thing, right hand side. We're going to substitute with the left hand side. So this becomes P or Q complement, we write that like that, or, right? Now putting this back all together, we using the conditional disjunction formula. We learned it before. P implies Q is equivalent to not P or Q, right? Same thing. So we have now P or Q implies R, which is where we wanted to go. Yeah. So pause the video at every step and see how to apply, right? It takes practice. It takes a lot of practice. It doesn't come on the day one unless you practice. So let's do some more, right? Let's do some more. So here we have another expression here. So same thing. We use a conditional disjunction, De Morgan's law, right? De Morgan's law, distributive law, right? That's you have to keep using the same and again and again. There's nothing fancy about it. So again, let's go and do it. My not P Q and not P or R, right? So we use the conditional disjunction. Now if you look at a distributive law is easy to apply, right? Common we have not P, not P. We have or and or. But here everything is or, so you can remember I told you if everything is just uh, or we can put together everything together. We can remove the parenthesis because the same parameters, same operators. So not P or not P or Q or R, right? And this one can be put together, this thing can be put together, uh, P or P is equal to P, right? So I can transform that into not P or Q or R, and I can rewrite this as not P or Q. I can do that. It is not going to hurt me, and not P same as the constructive conditional disjunction. So then we have P implies Q. I told you, right? This is not a rocket science thing. It's a simple thing, right? So that will do it, right? That will do it. Hope you'll uh, review the video and the assignments and practice a lot. Thank you.